With the vast amounts of gas discovered offshore, floating LNG production has become an alternative for shore-based LNG plants. By producing LNG offshore, a new era has started. The game is changing. LNG tankers will have to berth alongside the FLNG unit's manifolds to take on the LNG produced on board. Although this is an operation similar to normal berthing of LNG tankers, the unsheltered environmental conditions and the impact of waves can be a challenge. This animation clarifies how the rotor tug can contribute to the safety and reliability of these operations. In the standard procedure developed for this kind of operations, an amended push-pull method has been developed. Two rotor tugs sailing bow first establish a towline connection, one at the bow and one at the stern, always safe. The tanker is brought alongside and the tugs will move into the side of the tanker to push her against the fenders of the FLNG unit. Pushing into the side with standard stern drive tugs can only be done in good weather conditions. Maintaining an acceptable footprint with a stern drive tug is an impossible challenge during adverse weather conditions, with increased risk of hull damage to the tanker or the tug fendering. When the significant wave height increases, the unique propulsion configuration enables the rotor tug to keep position while applying forces on the hull of the tanker in the designated area. The risk of ventilation is minimized by the low position of the thrusters. If we have a closer look at the standard procedure developed for berthing LNG tankers alongside, and we combine this with the unique characteristics of the rotor tug, we would like to propose an alternative berthing procedure. This procedure enables the pilot to continue working in increased wave heights. We call this procedure rotoring or indirect towing at zero speed. Over the past 12 years, Kotug has developed this procedure especially for the rotor tug. This enhanced procedure for offshore berthing has been developed with the use of render recovery winches and synthetic wires and enables the rotor tug to assist on a short wire length. The tanker is brought alongside the FLNG unit, while the tugs stay connected center forward and center aft on a short wire. When she is in position and ready to be pushed against the fenders, the rotor tugs will push against the short tow line. The rotor tugs are in full control of the vessel while remaining inside the width of the tanker at all times and don't need to be repositioned to transfer forces onto the tanker. This alternative procedure mitigates the risk of damaging the hull of the tanker or the fenders of the tug and is only possible with the unique rotor tug configuration. The tanker can be brought alongside without even touching her. In severe weather conditions, when the tanker is receiving wires from the FLNG unit to be pulled towards the FLNG, the rotor tugs are still able to bring the tanker close and controlled alongside the FLNG, again mitigating risks and ensuring smooth production. The rotor tug system offers standard harbor tug maneuverability to large-sized tugs on extended deployments. Pivoting around midships offers a substantial advantage when operating in confined spaces or near strategic assets. The ability to pivot around midship, sidestep, and the rotoring maneuver increase the tug's safety zone significantly. The standard tandem operations for the condensate tankers can be done fluently with the rotor tug, due to the fact that the rotor tug minimizes vector response times for the pilot. When the tanker is hooked up, the swift response times of the rotor tugs minimizes the tanker movements, ensuring the tanker will stay within limits at all times. In these remote areas of operation, redundancy is of great importance. The rotor tug has two winches and can work over the bow and stern with the same ease. When a towing line breaks, the tug can turn around and make fast within minutes. The rotor tug is able to handle ships safely, even with one engine or thruster down. The unique friction-free towing point can be installed on the rotor tug in combination with the render recovery winch. The azimuth friction-free towing point will replace the staple and improve the assisting performance in adverse seas even more. Its unique configuration with excellent maneuverability and unique ship handling qualities minimizes risks, ensures smooth operations, and will enhance the overall safety of the operation. In the unfortunate event of an emergency evacuation, its station-keeping capabilities under any circumstances enable smooth firefighting operations and controlled transfer of personnel from the FLNG unit or from the water. The enhanced maneuverability of the rotor tug creates a controlled platform for pilot transfers from and to the LNG carrier, even at high speeds. Kotug has over 12 years combined experience with the rotor tug in various operations and different geographical circumstances, and we believe that this proven rotor tug system is the most safe and versatile option for this project. Rotor tug. We change the game together with you.